All right, ladies and gentlemen, epoxides can be opened in one of two ways. Scenario one, strong, new. Scenario two, strong, acid, catalyst, available in opening stage. Okay. So, do you remember triangles before? That question you were answering earlier today, like which carbon do the electrons come back to? You can say it, go ahead. The more substituted carbon? That works for triangles where a cation is present. When you learned it, it was only for triangles that had cations. Believe me, okay? These triangles don't have cations. One of them will have a cation in a second, and the other will never have a cation at all. So this one's not about carbocation stability. It's about steric hindrance. Scenario one is about steric hindrance. Which carbon in the triangle is easier to get to is the question. Top one or bottom one? Bottom one, less steric hindrance. H, much smaller than isopropyl. So you cross off your spectator, you put your lone pair and your minus, do a backside attack on the least hindered carbon. Not the most substituted. No. That's a backside attack, and you broke a dashed bond. What's the backside of a dash? No, what's the backside of a bond pointing that way? It's a bond pointing this way. What's that called? A wedge. Do you see the OCH3 on the wedge? Are you surprised? No, you're not surprised. But we don't get the product yet. We get something very close and very related. Got an O minus right here. Oh, and I noticed there's a mistake that I had in this morning's video too. I'll fix it. There's your OCH3. This morning, I forgot to put a solvent here. HOCH3. That's a solvent and a source of protons. And it's a poor nucleophile. So you wouldn't use it instead of O minus, would you? You would not make the mistake of reacting O neutral as a nucleophile before O minus as a nucleophile. You will never make that mistake, right? Good. So right now, I have an O minus, and it needs to pick up a proton. Where's it going to get it from? The methanol that you put on your underneath your arrow. Please put it there if you haven't done so already. And it looks like I have to cross an arrow. So I'll do a rare pink arrow mechanism. So you know which arrow is what when they're crossing there. And you're done. It's an easy mechanism, isn't it? Next one's got one more level because it's got a catalyst. And I want to see who can take a stab at guessing what happens first. I got nothing to cross out. No metals from column one. Please don't react methanol, a weak nucleophile, before reacting sulfuric acid, a strong acid. What's the best thing for sulfuric acid to react with? Keeping in mind, you do want to open that epoxide. So what do you want to do with the sulfuric acid first? Sorry? Get rid of the H, but where's it going to go? What atom gets it? No. The O. Which O? Yeah, I like that. Her answer was this. It's a great answer. I love nonverbal answers that are very accurate. Okay. So, yeah. This thing needs to pop open, so it'll help if you protonate it. So it doesn't have to be an O- when it pops open. Hey, there's a cation now. When there's a cation in a triangle, which carbon do you like to attack? We're back to our originally programmed cation discussion in a triangle. Which carbon's helping the plus charge the most? The more substituted carbon spends more time with a plus charge. Hey, this is not the first time I've said this. You know that, right? Okay. So guess which atom gets attacked by the methanol? You can say it again. The more substituted carbon. And you've got the oxonium version. Oh, I can't draw an octagon. I'm not great with octagons. Need some practice. So that pushed the old isopropyl back. And you've got the methanol. We put the new thing in blue. There's another oxonium, and the OH is still on a dash. And you tell me how to go from there to there. And don't forget, we have to account for this word right here, right there. We have not accounted for this word with our mechanisms. So what do I have to put on the page first? And then what do I have to do with that thing I'm putting on the page? The conjugate base of sulfuric acid, which you made in step 1, which makes it appropriate to put right here. Grabs H, neutralizer ether, and you're done. Too big, too small. There we go. And then we can fill in our blank and call it a video. These two products have opposite blankivity. Don't say stereoselectivity. They're both anti. New group OCH3 is anti to old O. New group OCH3 is anti to the old O. So they're both anti. Stereoselectivity. What's the opposite ivity? It's the other one. Regio. Try to make it look a little fancy. No, that's too big. One size smaller. Region. Selection. Region selection. And there you have it. Make sure you get that one copied out.